I want to show you something, right? What would happen here, Nathan? What would happen here? If I gave you something like this, right? And I said, take this line, I'll do it easy. I don't know. Which one to show you? Let me show you a line. If I take this line, single line, and I rotate that line 360 degrees about the x-axis, what would it form? L comma. Right? So imagine you have a line and you rotate this line 360 degrees. Right? L comma cylinder. We could use integration to find the volume of that cylinder. So if I rotate this 360 degrees between A and B, right, it will form something like this. Right? And I was telling somebody this could be a project, right? Take a cylinder and compare, work out the volume and compare it to the actual volume of the container. So we are off by a little bit, right? But this here, the volume of this shape, right? The volume of this shape, we could find it using integration, right? So the volume generated, well, I have to run away for 2 minutes to buy some marker. Volume now go in between maths and I'll fight up with it. Volume generated when the function is rotated. Online, you'll see that. I can be a right? Volume generated when f of x is rotated 360 degrees about the x-axis. All right, but they don't have black and blue. Anyway, right? Here's the formula. The formula is the integrating between B and A. You're integrating, I want to be a little specific. There should be y as f of x. You're integrating y squared. Very important, you square the y with respect to x and you're multiplying it by pi. Huh? Right? All this came from the proof, right? But basically, in order for you to get the volume, there's a way to do it, right? Copy it up. And I want to show you an example, right? Copy them. Oh yeah, copy down and let's try one. I just type it down. And we got good one. Are you ready? And let's copy it out. So you see, we are still in there, already, so it's usually 4, right? Are you ready? So here's what we're doing, right? The portion, write it down. Number 1. I just want you to get used to the wording, right? Follow is just one little formula we're using. I want you to get used to the wording. The portion of the curve y is equal to x squared. The portion of the curve y is equal to x squared. Between the portion of the curve y is equal to x squared. Between x is equal to 1. Between x is equal to 1 and x is equal to 2. Is rotated through 360 degrees. Is rotated through 360 degrees about the x-axis. Is rotated through 360 degrees about the x-axis. Find the volume generated. Find the volume generated. Right? Earlier, what I also want to do is not part of the question, but just so that you're, I mean, for me to understand that, for me to know that you'll understand the shape being formed, I want you to take this and see if you can draw the shape being formed. Right? Try and see if you can draw the shape. It's not part of the question, but I want to see if you understand how this is being generated. So in your mind, try to rotate this 360 degrees, and I want to see if you get a diagram right. All right. So try to draw the volume generated using this single line. Well, curve. All right. Real simple. Look at this one, and you'll figure it out, right? Please remember that these two sides equal. Huh? I saw somebody draw a bigger circle here. That's not. iPhone on it? Huh? Right, complete diagram. Yeah, complete diagram. Take your time, right? Right, correct. Are you? Oh yeah, work it out. Let's work it out now. Find the volume now. Yeah. Right. Oh no, we can do the question together. Understand what I mean? We do it together. Right, so I'm going to the shape you end up with, right? So basically you're reflecting this underneath here. Let me get it right little thing. And then you connect it up, right? Right? So it looks something like that. Right, how do we find the volume now? So the volume generated is pi by the integral, right? What is here there? Nathan, what is here? Right? Remember the formula is y squared. So you're writing what is y and you're squaring it. Okay? So you have to remember this, right? People tend to forget to square it out. Right? And you're good to go after that. Right? So that'll be the integral between 2 and 1 of x to the 4th dot dx. Jeremy? What's the integral of x to the 4th? What would it be? X to the power of 5 on 5. Anything else? No plus c, because no plus c. You all telling the man it's not plus c. Exactly. Guys, I must listen to them for us. Right, plug in 2 and plug in 1. So that is 2 to the 5 over 5 minus 1 to the 5 over 5. And you're good to go. And your unit it'll be units cube because it's volume, right? Online, you're okay with this? So please remember, whatever you get for y, you have to square it and then integrate it. Emirates, are you okay with that? Elizabeth? Barrow, you okay with it? Wait, I'm gonna respond some them as yet, but Barrow is Barrow good, right? Elizabeth, following? Yeah, relatively good. All right. So, but Barrow to doing one thing. Barrow still good? How much is this all?
19.4
You multiply by 5.
Yeah.
Anybody else get up?
Yeah.
If you want, yeah. With the pie on the outside, once again. Pi by this value, right? 31 over, huh? 31 pi over 5.
Yeah.
So 31 pi over 5. 31 pi on 5 units. Q. Right? Q because it's volume, right? What is it? That okay with that? So basically, that's it, right? It have other options, but on your syllabus, you only have to learn for the exam. Right? You can also rotate about the y-axis. Okay? Well, tell them, hey, it's not my syllabus. So I wanted to try some what is my but ready? Ready? Number 2. Nasser? It will get after. After. Yeah, me right here, we walking around the super clear about me. Are you ready? Number 2. Are you writing still?
Yeah.
Find the volume generated. Find the volume generated. Find the volume generated when y equals x squared plus 1. What are you looking for, Joshua? What are you looking for? What's up, you're looking for? You don't say. Find the pardon me, ma'am. Yeah. Minutes you.
That's right now about
Find the volume generated when y is equal to x squared plus 1. Are you right? Y is equal to x squared plus 1. All right, did it. Right? It's rotated about the x-axis between 0 and 2. About the x-axis between 0 and 2. Y is equal to x squared plus 1 is rotated about the x-axis between 0 and 2. Okay? So when this is rotated between 0 and 2, x squared plus 1. Go ahead. No diagram. You have to draw that. The diagram will just make sure you understand what is generated. Take your time, remember you have to square it, right? And take your time when you square, right? Maybe we have to plug in ourselves. Any questions online? Online, please send your answers. Everybody. I mean, yeah, it's fine. Right, I seen a mistake here. I seen a mistake with the expansion, right? Right, some people expand bad, right? You wouldn't be, yeah, you wouldn't be able to use that much. You see, once the denominator and with the x term, then don't use that method. Right? So when you expand here, you'll get x to the fourth plus 2x squared plus 1. Right? Some people expanded wrong, right? Huh? What? What's the formula? And it's y squared. Right? So it will be this squared. No, you have to expand it out and then integrate. Yeah. Once it's to the power 2, yes. Otherwise, no. Then you are is a different method. You how to use the next method again. Yeah, but if it was to the power 3, then inside it'll be different. It'll be like 5x. Right, nice. Any answers online? Right, just take your time when you're expanding, right? Right, people get answers already. Yeah. And what you'll recognize the Zahara is that you don't have to multiply by pi, right? You can just see the pi on the outside. Right, just leave the pi on the outside. So it's some fraction by pi. All right, so when you integrate this, you'll end up with pi. Yeah, you'll get x to the 5 over 5 plus 2x cubed over 3 plus 1x, right? And then you plug in 2 and you plug in 0. 2 to the 5 on 5, 2 cube on 3 plus 1 by 2. Minus 0, so there's no need to even work out the 0 part, right? When you plug in 0 there, you'll get 0. How much you got here? 206 pi over. Right, good job, Elizabeth. That's how you got that. Great job. What you got the first time? It's 75 now. Just put both of them and take even 75 to the same thing. Barry, follow Anton. Renusha, you're okay, Sebastian. Sebastian, let's message Isaiah, tell him to wake up now. Where Isaiah, you know here. Alright. Right, but be careful with that square and thing in the personal, right? Right, right. But I'm taking going forward. Bring it up for the adjustments. Oh, right on Zoom. Save this message. Barrel, save this message, right? Yeah, Barrel, okay. Department by Alright, let's start earlier. Let us begin with this one here, 2012, number 6, part B. Right, we just focusing on volume today. That's not good, so my father. I don't know what to do. I don't know. That's not good. I can tell you what, right? Right, calculate the volume of the solid. Right, let me just highlight the one you're doing. That's 2012 number something party, right? I'll see that. Yeah, thanks, Sebastian. You wake up. Try that there. You'll see that the function is y is equal to x squared plus 2 between 0 and 3. And look at what it said, right? It said leave your answer in terms of pi, right? Right, send your answers, please, everybody, right? Take your time and do it, and then send your answer. Go ahead. This one, please. Y is equal to x squared plus 12. Way out. Right, you got right. That's right, 2012, number 6 part. But technically, Israel, all the Israel, on Manalausi, oh yeah, try that, please. Take your time, integrate it, book it out, and send your answers, right? People don't send answers already?
Yeah, I get that.
Oh, yeah. Oh, yeah. Let's see. Once you end up with that X on the list. You can time expand and you may example on the board and talking about it, right? So that it's right, and the questions then leave the answer into the pie, right? I've seen answers online, that's a good sign. That is a good sign. On the bucket of it right here, right? So it will be the volume here. It's pi by the integral, finish. Pi by the integral between 0 and 3 of x squared plus 2 all squared plus dx. Right, so you'll get x to the fourth plus 4x squared plus 4. You'll go that for the expansion. Yeah. Nice. Now you have to integrate it fast and then plug in 3 and 0.
Yes, so that's like this.
right? That's the integral there. And then I'm gonna plug in 3 and I just plug in 0. Do I have to plug in this 0 or the value is 0 already, right? Right? How much you got? What's the fraction? 483 over 5 unit cube. Right? Unit cube. Right? Plug it in and make sure you get enough in the calculator. Right, good job, Crystalline. Isaiah, wake up and getting it right. Good job, Isaiah, Sebastian. Okay, we came up there, Sebastian. Benicia, nice. Emmerich, nice. Jason, very good. Elizabeth, very good. What missing? Baru. Baru and Gans, come here. Baru. Copy down. Let's go again. What you got? What you got the integral? Baru? You got the integral? Okay, so you have to put it in the calculator properly, Baru. I think you should to do that properly Monday.
So that's what the.
4, 8, 3, and 5.
That's.
So the one you answer by 5,
Yeah.
but you leave the answer in terms of 5. What do you think? Can multiply 4 by 3. Can multiply, yeah, do the brackets first. 3 to the power 3 first. Then multiply by 4.
Well, I just.
4 by 3. Bracket 1, bracket 1. Yeah, the cube and then multiply. All right, let's go again. 5 to 4.
So.
2015 part C, we did it already. Here, 2017 number 6. This one here is 2017 number 6, right? Call it this topic by topic in the arm group, right? So you can always open it for yourself, right? Somebody can just share about this topic by topic in group this. Yeah. So you will have it. Try that, please.
Is there one that is on?
Right, so what Sanjeev just shared, you could just open it up in case you're not seeing it, right?
Yeah.
But why is equal to x equal to? I don't know, this rule like.
And people skip it. I said, they skip that.
Hi, smart. That fellow just said otherwise. Hi, how are you? What did the question?
This one,
No, 2 by just means 360. 2 by means 360. And radians. Right, the 2 pi just simply means 360, right? You just give it 10 radian. But oh yeah, people putting answers already on the still x over 2 squared is x squared over 4. Yes, Kai, you squared right. Elijah. Who's Elijah? Elijah didn't come. Oh, why that? I thought I was from that. Me, son. Let us get me. Kai is here. Message none again. Upside down. Jaden and Jaden coming later. Jaden finish. Rihanna did custody. Done. Now I is any answer already, right? Crystalline come today, Jesus. Remodel. So 3 months out again. But Isaiah come today, Caleb. Caleb, Badam. Caleb. Mikai. Everyone speak. I don't. Samir. I don't know ready. I'm gonna correct it now, right? So let's start. Barbara, waiting on you, right? I'll give you a little 2 minutes there. Get on again, true? Hi. What's the name again? Adrian. What's the last name? No, I know you had the last name, but I don't feel up for your name down on this side. Wait, you have to come out. Huh? You up left, right? Yeah.
X squared over.
At the square first. And then integrate.
Yeah, no, we're not squared, that is squared. So if we're not integrating with that function, if we're not integrating x squared into x cubed, and then integrating 4 over.
I integrate for the pretty chair.
But now it's x cubed over 4 over.
All right, let's see what you got. Right, I seen some answers, very good. Right, so the volume. Oh, shit, we need to cross. Right, so the volume is equal to pi by the integral. Right, pi by the integral between 6 and 0 of x over 2 squared. So that'll be pi between 6 and 0 of x squared and 4. Right, after you do that, or don't forget next week, learn about differentiation, please, for next week. Huh? Right? X squared and 4, that'll be x cubed and 4. And remember, you have to multiply that by 3. Right? So that'll be pi between 6 and 0, x cubed and 12. Right? Remember, if you're not sure, you can pull the 4 outside the integral and quarter. Right? And then plug in 6 cubed. Right? You can ignore this 0. How much is that?
18 pi.
Huh? 18 pi?
Yeah.
All right, nice. 18 pi units cubed. All right, very good. I want to give you one more. Of course, you will need to know your cost and radians, right? Barrow, you okay there? All right, let's go again, Olia. Right, there's one more one to do, but I think it has to do with cost and stuff, right?
That's a. So. And it's 2 pi.
Huh?
And it's 2 pi.
No, 2 pi just means 360 degrees. Remember, pi in radians is 180. So that's all the same about 2 pi.
2 pi.
On the outside, that's formula is pi. All right. 2018, number 6. Be careful with this one, please. This one is very tricky. I finished that screen already. I don't know what.
I wish that I did it. This is what we would get it.
Oh, yeah.
And yes,
Right, hurry up. Do that, please. You want me to start? That's 2018.
So it's
2018. Oh, yeah. Take time, we'll go down. Yeah, x squared plus x plus 2. Want me to start? Okay. How to increase this to take your time because the problem here is that we had to square that properly. Yeah. You have to square quadratic. That's what you'll come up with.
X is equal to 0, right?
Huh?
X is equal to 0.
Sorry, x is, yeah. X is 4 and 2. What's that? Oh, I have to finish the problem here. That question, thing.
There's people looking at us. Why is my screen on Zoom?
I think that's fine. X to the power 4. X plus 2x to the power 3. 2x gives you.
Everybody else.
Right, so remember, you should be trying to move this out. Right, you're integrating between what values? Right, but the problem is we have to square this. Right, I'm giving you 2 minutes, I'm gonna do that one on the board. Yeah. Right, remember the principle of squaring, right? Every term in the first bracket by every term in the second. Okay? That's the principle of squaring, right? Yes, ma'am. No, will not always be, no. It will not always be, it will vary. Two minutes again. Right, see, you're multiplying this, earlier, when you expand, you're multiplying this by everything here. This by everything here. Right, answers coming in there. Let's take a look at this. So, make sure it's all started right there. All right, let's see what we got. So making sure I do this expansion correct, right? X squared by x squared, x to the fourth, x squared by x cube. Right, remember you do it all, right? X squared by that, 3x squared. Now x by x squared, x cube, x by x by 2. Right, so here you should have pi between 4 and 0 of x to the fourth, x cube plus x cube is 2x cube, 3x squared, 4x squared, 7x squared. Anybody get that?
Yeah.
Right, so done with that. And then 6x plus 9. Nice. Right, but after you do all that, remember you still have to integrate, right? Unless somebody said I forget to integrate. So that's x to the 5 on 5, 2x to the 4 on 4, 7x cubed on 3, 6x squared on 2 plus 9x.
So we could cancel.
Well, you can simplify it out here. And then you plug in 4 and plug in 0. Again, you don't have to plug in 0. How much is it?
8495.
8, 4.
What?
Huh?
84,000. Oh, I guess 6 months.
Yeah.
Over.
I guess 6,000.
For that same thing?
No, I
Yeah, check it before you plug it in. Right, good job, Sebastian. Amrit. Hey, look, Adrian sent something, right?
Yeah.
Good job, Adrian, Renusha. Right? Eden, don't forget pi, right? Elizabeth, oh, you just work it out, all right, nice. Emirates, Isaiah, good job on you. Crystalline, just check back yours, Emirates, good job. Yeah, that's okay, decimal and then multiply by 5. All right, are you okay with that? Huh? Yeah, it's 5 by, like 5 on 1. Yeah. Right? All right, so that's the second, that's the last, not the last, second to last application, right? Next week, we're gonna combine kinematic, we're gonna combine differentiation and integration. All right, so I would like you to review, differentiation for next week. All right? And then we'll finish up the applications.